Hi again. So we are in chapter 3, Boolean algebra and its applications, the title. Here we have seen the relation between Boolean algebra and propositional algebra. In here we have seen Boolean algebra and logic elements relations here. Here we will be dealing with logic circuits, combination of the elements or connecting the elements together to make a circuit. Is there any restriction or not? We are going to examine it in here. So this video is related with this frame. And then we are going to see in general some of the properties of the combination circuits. So let's go into this frame. Now we have got the elements, logic elements, as we have seen before, and or complement or inverter element, NAND gates, NOR gates, XOR gates, XNOR gates, and fill-in high number of fill-in inputs elements. We have seen all those. Now, when we connect those together, we are going to set up a logic circuits. So when we say that we connect them together, we've got to pay attention because there are some restrictions that we could do, we cannot do, and there are some connections that we could do. So this left-hand side, the circuit that we see here, this green connection is allowed. What it means, the output of a gate could be connected to the inputs of different gates, as we see here. So already we said the fan out is the number that you can connect the output of an element to the different elements. So fan out in this circuit for this element is just 3. There are some limits for it. For example, the manufacturer of this NAND gate tells in the spec is the properties of this element. So manufacturer gives you the properties of this element, saying that fan out for this element, let's say 10. It means you can connect the output of this element output, to maximum 10 number of other elements. That limits. That means if you connect more than 10 elements to the output of this element, let's say 11 or 15, it is not going to work properly. Why it is not going to work properly? Because you've got a power on that wire here. So when this current come out of here, that current is divided, isn't it? The voltage is the same, but the current is divided. So the power that you transfer from the output of this element to this element input drops down if you connect more elements because of the division of the current here. So the less the power input you put to the AND gate means it may not work properly. Therefore, there is a limit or fan out restriction for the elements. So it is allowed, but there are some restrictions on it. So let's come this side now. Not allowed cases. No, more than restriction is not allowed. So if you look at here now, you've got the output of 2 different elements connected to one of the elements input. In here, the opposite. The output of element is connected to different elements inputs. Here, different elements outputs connected to one of the elements. This is not allowed because it is against the circuit theory rules, isn't it? If the output of this gate is, let's say, 5 volts representing 1, and this gate is output is 0 representing 0, when you do a connection like that, that means you are short circuiting it. When you are short circuiting it, so you don't know whether this is 1 or 0. So you are changing the information because one is was here, so for 0, 1 here. So when you put them together, this becomes 0, this becomes ineffective. So therefore it is not allowed. Another connection that is not allowed is that feedback case. The output of an element cannot be connected to the input of a previous element. So this is a feedback. When there is a feedback here, so this circuit becomes unstable. That means the output could be either 0 or 1. It would be changing between the 0 and 1. This state is called unstable state. So therefore, that feedback is not allowed. Different outputs connection to one input is not allowed either. So under these conditions, if you connect the gate elements to each other under the rules that we explained here, then we end up with a circuit. This circuit is called combinational logic circuit. Why it is said combinational circuit? Because these elements here, all elements are the gates that we mentioned before. If you introduce a new element which is called memory element to these gates, then the circuit becomes a sequential circuit. Sequential circuits is going to be examined in a different group because the way of analyzing is going to change a bit. Therefore, we are examining sequential circuits separately from the combinational circuits. What else we could say here? Here you are. So this circuit here is set up according to the rules given to us, allowed and not allowed ones. There is no any not allowed connection, and all the connections are the allowed ones in here. So this circuit has got 5 inputs, 1, 2, 3 here altogether, 5 inputs and 1 output. A circuit might have more than one output. For example, if you take the output from this one as well, so it becomes 2. If you take it from here, it becomes 3 output. So there could be more than one outputs and more than one inputs. We mentioned a bit about the elements manufacturing technologies. One of them is called TTL technology, the other one MOS technologies. Whatever the technology is used, the mathematics or the methods that we are going to examine in logic design course does not change. Therefore, whatever explained here is independent from the technology being used. But it becomes critical for some other reasons, so I'm not going to explain those here. But in the lab, we will be using the TTL, transistor logic. The DC power source is going to be 5 volts. For the other technology, it is 3 volts. So that means in order to run a TTL technology, you've got to use a bit high power. If you are using this technology, you are using less power to do the same job. So this technology is almost not being used anymore. So the other technology is the most common used technology. But in the theoretical examining level, there is no difference between those two technologies. That is the end of this video then. So let's escape from here and stop.